guys hear my voice or not? Testing one, two, three. One, two, three. Can you guys hear my voice or not? Right, let's go. Right, okay. Okay, let's start. Right, okay. First of all, going we are going to I will do some presentation on the uh, Guile scheme and SICP itself. Right, let's go. Uh, Here it is, presentation. Eh, eh, Check. Oh, it doesn't work. Right. Eh, how do I do this? Uh, PPT. PPT. Right. Okay, I'll just do it right here then. Right, yeah, that's not my name. Just make sure to do it. Okay, so we will try to uh, restate our previous session on Lisp, Guile, and all of that. So, as a quick introduction, Lisp is a programming language dialect that was made in 1956, 58 by John McCarthy in MIT, Massachusetts Institute of Technology. And after that, it has many descendants. But what we're going to look here is the part of Lisp that I have experience in. First, in 1975, around 20 years after John McCarthy, Steller and Sussman of the MIT AI lab made Scheme by proposing through the so-called Lambda papers. So Scheme itself is basically a programming language that is written for academic programming, programming language researches, and also for AI. So at that time, the Lisp dialect of family was well known as an AI language. Uh, yeah, as an AI programming language. Right. So in around 1993, yeah, around that time, the new project, which is well known if you have ever heard of Linux, of GCC, of many other GNU projects. I will detail it later in its own slide. But most important is that in the last decade or so, there are many other Neo-Lisp dialects which are getting more and more popular. The most popular, of course, is Closure, and Closure Script, which are a new language that is based on Lisp syntax with a few modifications. Most importantly is the use of matrices and maps as the additional fundamental data structure, while Lisp and Scheme and other traditional Lisp uh, is focusing more on list processing language as befits their name. Right. They're also Closure and Closure Script is designed to work with a host language. So Clojure works with Java. It can interop with Java libraries, Java programs. Clojure scripts can also do the same in browser because it compiles to JavaScript. So yeah, it's called transpiling, transparently compiling or whatever. There's also High, which is the same but for Python, and Fennel, which is also the same but for Lua or Lua. You have perhaps have heard of it as the language of choice for indie game makers, and it's also quite interesting. I would love to try it perhaps later after I finish this series of videos. Right, so let's move on to the next slide. Scheme. Scheme was created. Yeah, I quoted this from Wikipedia. You can read it by yourself. But the most important is that it has what's called lexical scope and tail call optimization. So this tail call optimization or TCO makes it that uh, scheme programs can be written 100% in the functional style without the need for loops for so you can just make a higher order function and put the result of the previous function into that. We can, I think it's on chapter 2 or chapter 3, so we will see it later. Scheme itself is a very diverse family of dialects, such as, for example, what we're going to use here is New Guile. There's also MIT Scheme, which was the language SIP is written for. There is also now popular Racket, and it I think it's the most newbie friendly now with Dr. Racket as a software suite. I would also love to try it perhaps later. And there's also Kawa, which like Clojure runs on this GVM and is actually the first language in the GVM that's not Java because it was started in 1996. There's also Chess Scheme, which was I think was a paid project, but was open sourced just recently. The Scheme uh, family of programming language have some standards which relevant nowadays is including R6RS and R7RS, both of which are supported by GNU Guile. So yeah, we can just see it later. And there are also many more proposals sent by the community in order to standardize uh, the various features and choices between these all of these implementations to be standardized together. We won't talk about this too much because I myself am a Scheme noob. I have no experience at all in Scheme, but as I mentioned earlier, I actually am able to program in some level of proficiency with Clojure. Not that good, but I think I'm decent enough to be able to make CRUD apps or yeah, extend some Java project. Perhaps we will see it later on. But yeah, in my work life, I've tried to use Clojure and Python as much as I can. Okay, let's continue on to new Guile. Right. So in the early 1990s, Emacs was one of the most successful program ever at the time because this was the start of the internet and the start of GUI, start of all of that. And why did Emacs became so popular? Uh, I myself am a film user, but yeah, Emacs is great. Emacs is great. It's just that I haven't bothered to learn much into it. Some people says that Emacs is its own uh, operating system, and that's actually have some kind of truth in it. Anyway, one of the major reasons for the success of Emacs is its implementation of Emacs Lisp. So Emacs has its own Lisp style language that is used for its own programming logic and also in order to make extension. Now, this emac Lisp language is was quite slow, and it was a DSL, a domain-specific language, with nearly all of its novel features engineered only for text editing and other applications that can run through a text editor, which is very many. Right. So in around 1996 or so, there were a couple of proposals inside GNU itself, so that uh, the whole project, not only each program, each application, each software, the whole project can implement the same extension language without needing to maintain unique DSL for each project. So there was some kind of issue if if a maintainer cannot just maintain the program that he wants to maintain, but also needs to maintain his own programming language as it is. So Guile was chosen, and after around 25 years, I think it's quite mature nowadays. But its main rise on the ether, its main uh, purpose is to interoperate with C language application through its C API, which we will not be using. But Guile, Ninu Guile, is actually just released last year, the version 3.0, sorry, which made it much faster because there is some kind of improvement in the GIT. And also, Guile is used as the language to maintain a GUIX system. GUIX is I don't know the meaning of the name, but it's the new counterpart to the Nix project, which is basically a declarative functional OS distribution for Linux. So these two projects make it possible for desktop, server, and even specific hardware users to maintain their software, their desktop installation just through one file and be able to sync it with many other computers at the same time, or perhaps if you've lost your computer and you need to refresh directly into another computer, you can just do it through your configuration file, and your personal data can be synced through your own backup. So there is no need to install an OS from scratch anymore. That's very interesting. And I actually wanted to try GUIX, but I cannot, I could not run the virtual machine that is given by the project. So we will see it later, perhaps next week or so. And I've looked around, and actually it's quite interesting that Guile is recommended by this developer from GitHub. His username is ZV or Polyswarm, I think, and he actually made a guide for using Guile in SICP. There's only one issue is that later in chapter 3, the book wants us to implement our own visual language, but because I'm using this from WSL, Window Subsystem for Linux, uh, which doesn't have UI yet, I haven't bothered to set up it. We won't we won't be able to do that, but yeah, we can just try it later. Perhaps I will try to use my Linux installation to do this. Right, okay, so next, what is SICP? So actually yesterday I've tried to summarize this whole book, but there was some mic issue and it wasn't working. So I will just quote the Wikipedia on this. Structure and Interpretation of Computer Programs is a computer science textbook by the MIT professors Harold Abelson and Gerald J. Sussman, with Julie Sussman, which, if you remember, is the maker of a scheme language. It is known as the wizard book in hacker culture, and it teaches fundamental principles of computer programming, including recursion, abstraction, modularity, and programming language design and implementation. And it's also a meme if you've ever tried to browse around for with other programmers in many uh, hanging out places, which I will not mention in this video. Not because I'm afraid of the AI system content or whatever. No, it's because we all know it. So rule one, bro. So because I'm a whip, I'm proudly a whip, and because I have seen this series of images of Toho girls and other random anime of the season girls with SICP, well, I am contractually obligated to at least read the SICP from cover to the end at least once in my life. So why not now? And we can read it together. So if there's any questions that you want to ask, just ask me or perhaps ask many other people at the same time. And okay, let's go. Famos. Okay, so we will continue on uh, to the okay. I will talk a bit more about the book first. So this is the text info format by Andre Sraba. Thank you. And again, because the license is CC Creative Commons Attribution Share Alike 4.0 International License, I can, we all can copy and use this book as long as we mention the owner of the copyright. And we also share it with under Creative Commons, which this video should be. So if you guys want to uh, remix away my voice or my video, feel free as long as it's used for good. Please don't use it for anything bad. Not because not because I will judge you, but also the whole society will judge you. Right, let's go. So there are five chapters in this book. The first is building abstraction with procedures. Procedures is what's called functions in many other languages. And the second is building abstractions with data. And now I will mention that in Lisp languages, all all source code is also data. So Lisp programmers can modify their own source code with their own procedures or what's called macros. And this is actually quite confusing. Quite confusing. I've used Clojure for around 6 months now, and I'm still not be able to do anything with it. So we will learn it together now. And it's also modularity, objects, and state. So interestingly, Clojure is not an OOP language at all. So it's not. Uh, it's a functional language, not a pure functional language like Haskell. It's an impure one because you can always import Java classes and objects into it. But if you want to write something idiomatically and and you want your source code to be able to be parsed and contributed by other Clojurists, you should stay with functional programming. But traditional Lisp like common Lisp and like Scheme is multi paradigm, I think. So again, uh, I think in chapter 3 we will try to make our own object oriented programming module in Scheme. Nugal actually have its own OOP system, but uh, I've researched around, and I think it's okay if we still implement the chapter 3 of this book. in Guile. But if I cannot, I will move to Dr. Racket, because Dr. Racket is also another scheme that is recommended for beginners like me and perhaps like you too. And number four and number five, I have no idea what they mean. Zero idea. Right, let's go directly into chapter one exercise. So I've done, all right, not this. After exercise one, two, and three before. So right, actually exercise 1.3 I haven't done it yet. So I let's do it now. Define a procedure that takes three numbers as arguments and returns the sum of squares of the two larger numbers. So this is actually quite interesting uh, procedure or function, because we need to make some we need to make uh, we don't need to make a flowchart for this, but I will try to describe it in this. We'll just use theme first to make it easy. Right, so define exercise 1.3, define a procedure that takes three arguments and return the sum of squares of the two larger numbers. That means that in pseudocode, I will try directly into writing in list. But yeah, sorry if I my default would be on closure or even in high. Right. So first define sum of squares too big and x, y, z. First, we need a condition where x uh, x is more. Yeah, I'll just use normal notation first, and we will clean it later into list style RPM. If x is larger than y and y is larger, uh, no, first x larger than z, and I think we can sort this. I don't know if scheme has it. Closure has some functions in order to sort lists and factors automatically. I don't think I don't think scheme has it. I don't know. I have no idea. So we'll try to use the syntax that has been given to us until now. Condition. So first condition is that if x more than z and y is also more than z. Okay. No. This doesn't work. This doesn't work. Oh, okay. This can happen. Z, yeah, Z, yeah, Z is less than X, and uh, Z is less than Y. Then, uh, then sum of squares. Right. So we'll just use it like this: times XX plus times XX times YY. Right. So that's the first condition. And the second condition would be if X less than Y and X less than Z, which would be the same, plus YY times XY, and also times ZZ. But the last condition would be if y is the list and y z time x times z z. Right, okay, so let's try to clean this. First, we will move n first. So it will be like here and this, let's move here and move this here. Right, and again, let's move n here, then lower than here, lower than here again, lower here. We don't want any bug at all. We can help it. It's actually quite interesting because I think Lisp and Common Lisp and Clojure is able to, right, try. It doesn't work. Right. Okay, okay, okay. So we can use and. Why? Because I remember it. You told me that and. And works like this, right? What is an and work? Check. One, two. Or perhaps my condition structure doesn't work. Alright, yeah, this is condition. Again, define. Yeah, I'm already right. Define sum of squares. Define. Yeah, right. One parenthesis. And this. Okay, so this must be two parentheses. Right. Right. Okay. Don't be afraid of all these parentheses. After a while, you'll stop noticing them because again, all the relevant parentheses will be highlighted for you, just like here. Right. And. Okay. Let's try again. Right. Okay. Now let's try testing this with how about 1, 2, 3 first. Sum of squares 1, 2, big 1, 2, 3. Well, what's with the type? Something is wrong. But I can't see where it would go wrong. Let's try again with break tries. And no, 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 not that. Okay, you are. Okay, you crashed. Bye. Right, try again. For this, we will try to debug using the backtrace. Okay, sum of squares 2, big 1, 2, 3. Right, I have no idea why that doesn't work because it should work. It should work. we will try to check some of the logic first if it does work or not. So we'll try this. Oh yeah, I mean uh ah okay. 1 2 1 3. It's true. It works. I have no idea why it doesn't work. How about we try something else? How about we try using sum of squares to big 5, 6, 7. What's wrong with apply? I don't want anything. I don't want any type. You're blaming me for doing this wrong. Okay. Let me cast a check here first, and I will try to continue this on with my in my own time. Okay. Uh, Let us move forward into exercise 1.4. Yeah, I'm using my wizard hat. Right. Uh, okay. So let us observe our model condition. Okay, good expressions. Define a plus apps b a b if b is higher than 0 and it's positive, negative, a b. What the heck? A plus b apps. Oh, right. Yeah, so this means that if b is higher than 0, then it's still b. But if uh, b is lower than 0, it becomes minus. So a plus b or a minus b, which is quite interesting. Yes, yeah, it works like that. It works like that. Let's try this in our own. Right. Let's try this in our own interpreter. Let's go. All right. So, okay. Let's change b into 1 and a into 2. Mean plus mean 2 1. Huh? Why is it unexpected? What? What? Why is it unexpected? I have no idea. Okay, let's continue on. Okay, so 1.3, 1.4, I will need to solve it in my own time later. That's 1.5. Ben Bitdiddle has invented a test to determine whether the integrator he is faced with is using applicative order evaluation or normal order evaluation. He defines the following two procedures, and then he followed the expression. Right, so applicative order and normal order evaluation. Yeah. So if we are using the applicative order evaluation, which is what scheme uses, so first, uh, P is P, correct? So that's one. And the test function would be uh, test xy. So x is into 0. So because 0 equals 0, then it will output 0. But normal order evaluation, that's normal order evaluation, I think. But effective order evaluations will crash if y. I don't know. Okay, we'll try this now because I'm actually quite interested. Okay, we have to define P, PP, big PP. Then we also define test procedure, right? So then let's try test 0 P. Does it work? It doesn't work. Wow, it doesn't work. Huh? Right, so it crashes because P is something inside its own list, which is should be not good. Okay, now 1.17 example square roots by Newton's method. Procedures as introduced above are much like ordinary dimensional functions. They specify a value determined by one or more parameters, but there's an important difference that procedures must be effective, right? Yeah, so that's the difference between a mathematical function and a computer programming function. Programming functions must have its output. So from input to output. While a function doesn't need to. Define squared x dy and equal or larger. Y is equal or larger than 0. Then we just need to square y if it equals x or not. Yeah, that's just a commutative identity function. Not it doesn't really do something productive. Right, so this is the algorithm to compute square roots through Newton's method of successive approximations. Okay, 1.5. Whoa, whoa. Yeah, yeah. So this is actually the numerical analysis method of computation. So because computers is imperative, you should not be you cannot use you cannot make computer think like human in mathematics. So that means you need to make the mathematics fit into how the computer is thinking. And yeah, let's try the procedure here. Alright, okay, so first I'm going to write 1.17 Newton's approximation for square root. Okay, so the will be first we define squared iteration quest x if good enough quest x quest squared iter improve quest x x. Right, so we actually cannot use this directly into the interpreter because we haven't defined the inner procedures or inner functions inside that function. Okay, so first we define improve quest x as, again this is the body, so average quest divided x quest. Alright, and we also define average, so everything must go upside. This I learned this from closure, because if not, something bad will happen. Plus xy 2. Okay, good enough. Good enough can fit here. Define good enough. Press x. Absolute. We've already mentioned absolute here. We'll see later. If it's errors, I can just. No. I'll put absolute first. Absolute. Okay. Define abs x if x less than 0, and then we minus x. If not, just put x. Okay. Where we define squared x. One point zero x. Right. Okay. Let's copy all of this into the interpreter. Actually, I can just put DRPL Guile here using my nvim add-on. Okay, first, okay. How do I change back to yo? Yo, I can change back. Yo. Fuck it. Okay, so yeah, it's not like okay, it's kind of yeah, the absolute right. Okay, no issue. Then define average. Done. Okay, now improve quest. Right. Then define good enough. Oh, right. So we haven't bound square yet. Square is this. Let's just define square directly. Define square x, which would be times xx. Right. So finally, we just need to define squared iteration, and then we can just define square. Right. So last procedure, and after that we can try directly. Right. Okay, let's try just like by the book. Squared 9. Yeah. Right. Squared plus 107, right? Yeah, they're really the same. Well, we just copy the codes anyway. I should have just type in the codes. I will do it starting now. But again, this is just to make it faster for you guys. Yep, same answer. And then we just square, square. Okay, square, square 1000. Right. So this is the error because we use numerical analysis instead of the quality of the functions themselves like we do in paper-based mathematics. Right. So why does if? Right. So yeah. So again, this is quite interesting, right? In Lisp languages, you can just define a new procedure to replace the default procedure or default syntax of the language. In Python, you cannot. Uh, there are some people who will try, but well, it's quite hard. Other languages, in some languages you can, in many others you cannot. But again, some will ask, why would you want to do this? And my answer would be, why not? It's cool after all. It's very cool. Right. Even demonstrate the programs for this. I think we'll do this exercise for the last exercise for today, and we will continue tomorrow after this. Okay. So if I try, if we talk about this implementation of the new if procedure, so the new if procedure has three operands, which is predicate, then close, and else as close. So it will use con predicate, then close, and else as close. Right. The issue here is that because he used else, she used else, if uh, the condition does not include the predicate, or then it won't run the else clause. It will just error. Let's try it. We'll try it now. Right. Then we'll try new if times 2305. Yeah, it's equal there. But what if we put uh, equals to 200? All right. Yeah, it works. It works. But it shouldn't work in uh, it shouldn't work if it's too much. Okay, let's try. But I need to change the name in order so that okay, just put it new skirt item. New new skirt item. Okay, we'll try. Okay, new skirt item 1.0. Does it work? Does it work? If it doesn't work, we don't know why. It doesn't work. But the Guile interpreter doesn't give us an error, which is sad. Perhaps you can cancel it. Cancel it. Right? NBT, nothing to debug. Still doesn't work. I think it's because it's using cont, and good enough is a function that doesn't return true. Does it return true? Check good enough. Guess x absolute minus square guess squared is divided by x and by x is lower than 0.01. Yeah, it doesn't return true. That's the problem, I think. Because it doesn't return true, it cannot be used in the new if. Right. Yeah, so that's the issue. It leads to segmentation fault because there is a repeated allocation of very large block with a size is this is bytes. So wow, 156 megabytes. Yeah, that's yeah, that's a very catastrophic result. Oh well, so that's how it is. Okay, thank you for listening to me today. We will continue on tomorrow with exercise 1.7 and we will try to continue until we finish the chapter 1 perhaps in this week. Thank you very much. See you tomorrow. Auf Wiedersehen.